Hello my precious friends, I really hope that you are doing great. Welcome to today's class. It is our 5th lesson on the 10th topic of Form 4, which is called radioactivity. As usual, let me commence by giving the quote of the day, which states that regret is the poison we get after failing to take the right action. We shall discuss that quote at the end of our class today. So remember, in our previous class we did look at the formula for finding the half-life, whereby we say that n is equals to n naught multiplied by a half to the power of t divided by small t. So in this lesson we are simply looking at examples of how we can apply that particular formula. So our first example reads that the initial mass of a radioactive substance is 20 grams. The substance has a half-life of 5 years. Determine the mass remaining after 20 years. So we said that n is equals to n naught multiplied by a half to the power of t over small t. Of course, where n simply was representing the number of nuclides remaining undecayed. Therefore, in this particular question, n will simply represent the amount of mass that will remain undecayed. Then n naught was actually representing the original number of nuclides present. Therefore, n naught in this case will represent the initial mass or the original mass before the decay process actually took place. Then capital T was actually representing the total time of decay. Similarly, so our capital T will actually be 20 years. Then small t represents the half-life. That is the time taken for half the mass initially present in the substance to actually decay. Therefore, n, which is the remaining mass undecayed, will be n naught, which is our initial mass, which was 20 grams. So 20 multiplied by a half to the power of capital T is the total time taken for the decay process to take place. So we are told to determine the mass remaining after 20 years. Therefore, the total time taken for the decay process to take place will actually be 20 years, then divided by the half-life T. So we are told the half-life is actually 5 years. So this will be 20 multiplied by, remember a half is the same as saying 0.5, then 20 divided by 5, you're going to get 4. So if you take 0.5 to the power of 4, you're going to get 0.0625. Therefore, 20 by 0.0625, you're going to get 1.25 grams. Therefore, this is the remaining mass after the decay process has taken place. Our second example reads that if a radioactive isotope has a half-life of 2.5 hours, how long will it take for 256 grams of the isotope to decay to 32 grams? Again, we are simply using the same formula that the n is equals to n naught multiplied by a half to the power of capital T over T. So of course, n simply represents the remaining mass in this particular case. So we are told that if a radioactive isotope has a half-life of 2.5 hours, how long will it take for 256 grams of the isotope to decay to 32 grams? Therefore, it means the remaining mass is 32 grams. Then of course, the original or the initial mass was 256 grams because before the decay process took place. Therefore, our n naught, which is the initial or the original mass, was 256 grams multiplied by a half to the power of total time taken divided by the half-life. Therefore, we are given the half-life as 2.5 hours. So on dividing both sides by 256, I'm going to have 32 divided by 256 being equal to a half to the power of total time taken, capital T, divided by the half-life, which is 2.5. So if you take 32 divided by 256, you are going to get 0.125, which is equals to a half is the same as saying 0.5, then to the power of the total time taken T divided by the half-life. So for me to solve this, I'll have to introduce a log to base 10 on both sides, the way you learned in mathematics. So introducing logs to base 10 on both sides, I'm going to have the log of 0.125 being equal to the log of 0.5 to the power of t over 2.5. Therefore, this will be the log of 0.125 being equal to, remember from the laws of logarithm, whenever you have a power, it can always pre-multiply the log. Therefore, t over 2.5, it will pre-multiply this particular log. Therefore, I'll have t over 2.5 multiplied by the logarithm of 0.5. On dividing both sides by log 0.5, I'm going to get log 0.125 divided by log 0.5 being equal to t over 2.5. Therefore, if you take log 0.125 divided by log 0.5, the answer will be 3. Therefore, 3 is equals to t over 2.5. Multiplying both sides by 2.5, I'll get t being equal to 3 multiplied by 2.5. Therefore, the total time taken will actually be equal to 3 by 2.5, which gives us 7.5 hours. Next, we look at our third example, which reads that for a certain radioactive material, the average count rate is found to be 82 counts per second. After a time of 210 seconds, the count rate had dropped to 19 counts per second. Then the average background count rate remained constant at 10 counts per second. What is the half-life of the material? So in radioactivity lesson 4, we did say that whenever you have background activity, then you have to subtract it from the recorded activity in order for you to find the actual activity. So we said that actual activity is given by recorded activity, then you subtract the background radiation. Therefore, our actual final count rate, denoted by n, will simply be given by the final recorded activity, then you subtract the background radiation. So the final recorded activity was 19 counts per second because it had dropped to 19. So 19 counts per second, then minus the background count rate, which was maintained at 10 counts per second. So 19 minus 10, you're going to get 9 counts per second as the actual final count rate, or the actual remaining count rate. Therefore, we also find the actual initial count rate, n naught, will just be the initial recorded activity, then of course minus the background radiation. So the initial recorded activity was 82 counts per second, then minus the background radiation was maintained at 10 counts per second. Therefore, 82 minus 10, you're going to get 72 counts per second as the actual initial or original count rate. Then the total time taken for the decay process to take place was 210 seconds. We are told after a time of 210 seconds. So this is the total time for the decay process. Then of course we say that n should be equal to n naught multiplied by a half to the power of t over small t, where of course n in this particular case simply represents the actual final count rate, or simply the remaining count rate after the decay process. N naught will represent the initial count rate. Then of course capital T is the total time taken for the decay process, or for the counting process to be completed. Then small t will represent the half-life. Therefore n is actually 9, which is equals to n naught will actually be 72, then multiplied by a half to the power of the total time taken, that is 210, then divided by small t. Therefore 9 is equals to 72 multiplied by a half to the power of total time taken is 210 divided by the half-life represented by small t. Therefore, on dividing both sides by 72, I'm going to have 9 divided by 72 is equals to a half to the power of total time taken 210 divided by small t. So if you take 9 divided by 72, you're going to get 0.125. Then of course a half is the same as 0.5, then to the power of 210 divided by t. Introducing log to base 10 on both sides, I'm going to have log of 0.125 being equal to the logarithm of 0.5 to the power of 210 over t. Then of course from the third law of logarithm, that you can always take the power to pre-multiply the log. So this is the same as saying 210 over t multiplied by log 5, then of course is equals to the logarithm of 0.125. Dividing both sides by log 0.5, I'm going to have log 0.125 divided by log 5 is equals to 210 over t. Therefore, we are going to have logarithm of 0.125 divided by log 0.5. You're going to get 3 as the answer. Therefore, 3 is equals to 210 over t. Of course, if I multiply both sides by t, I'm going to have 3t is equals to 210. Therefore, T will be 210 divided by 3, which gives us 70 seconds as the half-life of this particular material. Next, we look at our fourth example, which reads that the figure below shows a graph of number of counts against time. Then the data used to plot this graph was obtained from the reading of a counter connected to a Geiger-Muller tube placed in front of a radioactive source. Use the graph to determine the half-life of the material. So this is our graph. So you can see number of counts. So the original number of counts was actually 120 counts. So they want us to find the half-life. So remember, we defined half-life as the time taken for half the number of nuclides initially present in a radioactive sample to decay. So because initially we had 120 counts, it simply means that the half-life will be corresponding to a half of 120 counts. So a half of 120, of course, will be 60 counts. Therefore, a half-life will be equivalent to the time that corresponds to 60 number of counts. Therefore, a half of the initial number of counts was 120, so a half of 120 will give you the 60th count. Therefore, the time corresponding to the 60th count is actually what we are calling the half-life. Therefore, the half-life for this case is actually 30 seconds. Lastly, I have an exercise that I recommend you should try at your own free time to get the understanding of the concepts that you have just learned. Of course, if you have any challenges in handling any of the questions, feel free to drop a comment specifying the question that you need help in. And as usual, I'm always here to try and help where possible. We've come to the end of our class today, but we need to discuss the quote of the day. The quote of the day stated that regret is the poison we get after failing to take the right action. So the quote is reminding us that unless we take the right action and make the right decisions in life, we are bound to suffer the pain of regret. We should therefore always be prepared to take the right action whenever an opportunity arises, because you will only feel lucky if an opportunity meets your prepared mind. Otherwise, if your mind is not prepared for the opportunity, then you won't enjoy that opportunity. And lastly, recall that it's better to look ahead and prepare than to look back and regret. Thank you very much for accompanying me until the end of this particular lesson. I do not take it for granted. In case you are new to the channel, kindly hit the subscription button and also turn on the notification bell so that whenever I upload a new video, you'll get notified. Until next time, this is Kind Tuition Academy. Thank you very much.